risk, even with twins, is 40 times higher than with a singleton pregnancy. So we're very focused on developing the techniques so that it is quite possible for people to do elective single embryo transfer on as many patients as possible. Certainly all the younger patients, certainly patients who are on their first 2 cycles or whatever. And this can only be achieved if the laboratory systems are optimized. Having said that, the laboratory is dependent upon the oocytes, or the eggs that come from the woman, and the stimulations that we use, or that the doctors use to help those oocytes or eggs develop, are very, very important. Small variations in those protocols can have major impacts on the competency of the eggs. The eggs may look just the same. The embryos on the first few days may look just the same, but there is something that is not ideal that has undermined the competency of those eggs, so that the embryos they produce are less competent to make a successful pregnancy. So we must be very, very careful that the laboratory optimizes its systems so that we can then identify where those variations might be occurring in the stimulations. Some of those variations are due to the patients themselves, because many of these patients obviously have their infertility problems that could relate to the function of the ovaries. But there's also this issue of whether the stimulation is just right. If it's just right, we get fantastic results. If it's not quite right, we can still get good results, but they're not going to be ultimately the best results for the patient. The best result is to be able to put back one great embryo and have some other great embryos that we can cryopreserve by slow freezing or vitrification, depending on people's preferences. And then patients have access to those in case they don't get pregnant with the fresh embryo, or they do when they want to come back for a second or even a third child. One good stimulation cycle can generate an entire family.